Hello friends, very good morning all of you and welcome to the Excellent Science YouTube channel. Friends, before I start today's lecture, I would like to give you some information, and the information is related to your preparation regarding CUET and NEET UG. So the basic information is that we are going to launch a crash course in the Excellent Science YouTube channel platform, which is going to be held from last week of the March. So it's very good opportunity for you because the lectures here are going to be free of cost, and if you are interested, it's a greater opportunity for you to join us together. So this is information which I wanted to share with you, and I have also a suggestion for you that those who want to join us and those who have applied their form for CUET or NEET UG, I will help you completely towards the problem related with the subject of physics. So it's my suggestion for you to share this information to your friends, those who are preparing for their CUET or NEET UG exam. Okay, thank you very much. So let's start with today's lecture. Now today's lecture is well known to you, that is Coulomb's law. So what we know about the charges, that charges are of two types, that is positive and negative, and we know that same charges repel each other while opposite charges attract each other. Even the property of repulsion or attraction of the charges was ubiquitous, we can say. It was clear earlier. But how the charges attract or repel each other? The clear reason that there must be some force which should act between them. But there we don't have an adequate information about the force acting on the two charges. Even after Thales or Gilbert's information which they prevailed about the two types of charges. So Charles Augustin de Coulomb in 1785 established a relation which could explain the force acting between these two charges, and how the relation is going to stabilize between the charges and force. So he was not the first, but he gave a valid explanation on the basis of his experiment which he performed on torsion balanced. So when Coulomb performed his experiment, he found some facts on the basis of which he postulated some assumptions, and the assumptions were that the first one, he found that the electrostatic charge or of attraction or repulsion is directly proportional to the magnitude of the product of the two charges. If we consider we have two charges, and the charges we have two point charges, especially when we are going to discuss Coulomb's law, we should have points in our consideration, and that point is that the first one is that charges should be point charges, and the second one is the charges should be stationary or steady, because Coulomb's law works only for the steady charge, stationary charge we can say. It doesn't work for moving charge. So whenever you are going to apply the Coulomb's law, must keep these points in your mind. So first, consider we have two stationary charges here, charge plus q1 we can say, and here another charge q2. Initially we consider that both the charges are of same polarity, and they are separated at a distance small r, where r is the separation between these two charges. So according to the experiment Coulomb performed, he found that the force acting between two charges is first point, let me write it here. The first point he postulated was that force acting between two charges is proportional to the magnitude of the two charges, that is product of the magnitude of the two charges, proportional to the product of the magnitude of the two charges, product of the magnitude of the two charges, charges, that is we can say F directly proportional to Q1 multiplied with Q2. Now the second postulate which he found was that this force is inversely proportional to the square of the distance of the separator between two charges. That is, if inversely proportional to the square of the distance, that is r square. So when we combine these two, we get if directly proportional to the q1 q2 divided by r square. We can also mention it as inversely proportional to the square of the distance, square of the separation, we can say separation. This is. Now when we combined, we found F directly proportional to Q1 Q2 by R square. Now our motto should be to remove the proportionality sign, and we know clearly when we remove some proportionality sign, we need to put equivalence constant, and that constant is F is equal to K multiplied with Q1 Q2 divided by R square, where K is simply any constant, or we can say it is Coulombian constant or Coulomb constant. So now this constant K is also replaced by K is equal to 1 by 4 pi epsilon naught, where and its value is given by 9.0 into 10 over the power 9 Newton meter square per Coulomb square. When you are going to write the value of K, you need to be very clear, or you need to be quite clear with the unit, that is Newton meter square per Coulomb square. So K is equal to 9.0 10 into 10 over the power 9 Newton meter square per Coulomb square. So where what is epsilon naught? Where epsilon naught is the permittivity of free space. Permittivity of free space. Free space. So now we can replace K with 1 by 4 pi epsilon naught. So another form of Coulomb's law becomes you need to note all these points which I have mentioned here. After replacing K is equal to 1 by 4 pi epsilon naught, we get F is equal to 1 by 4 pi epsilon naught multiplied with Q1 Q2 divided by R square. This is called Coulomb's law, and this is also the expression for deducing the force acting between two charges. Now we know that charges are of two types. So in first case, if we consider one thing I need to mention here, that the force of attraction or repulsion is direct always in the line joining the two charges. Okay, so I would like to mention here, if we consider if charges are of same nature, that is they belong to same polarity, either positive or negative, same nature or polarity. So we consider in first case we have two charges of same polarity, that is Q1 and Q2 are going to be both positive. Now, same charges repel each other. So, force of repulsion will be there and the direction of these two forces will be equal to. So, if we consider it Q1 and if we consider it Q2. Now, Q1. So, this is F12, that is force applied on first due to second. And this is F21, that is force applied on second due to first. So these two forces are repulsive in nature. We can replace the positive sign with negative ones, like, but they should be same. Again the same thing happens and they repel each other. So again we need to put everything which we have written here in this section. So when the charges are of same polarity, the force acting between these two charges is called the force of repulsion, and in this case the force is going to be positive. That is, we can write F here as F 1 by 4 pi epsilon Q1 multiplied with Q2 divided by R square. You don't need to put a positive sign before, because positive sign is present itself everywhere where the negative is not applicable, we know well. Now, in the second case, if we are going to consider that the two charges are of opposite polarity. Second case, if charges are of opposite polarities, that is, one is positive and second is negative. So we can express here as positive and negative. You can interchange their position, and the difference I have not mentioned. Consider R. Now, the force between two opposite charges is the force of attraction. That is, they will attract to each other like this. If this is Q1, this is F12 force on first due to second. It is F21 force on second due to first. This is the force of attraction. When two charges are going to attract each other, the force between them is expressed by F is equal to minus of 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now, you need to be clear for one thing, and that is, while solving your problems, if you find negative sign before the for the force, you don't need to be panicked. What negative sign indicates there? Negative sign indicates only that the force acting between the two charges Q1 and Q2 is the force of attraction. There is no use of negative sign instead of this. So negative sign indicates that the force is the force of attraction. Okay. So these points should be clear. Now let's move forward and discuss what are the limitations of the Coulomb's law and how does it work. Or we can say what are the necessary conditions for Coulomb's law. So important points we can say. So first important points, that the two charges must be of units of point charge. Now one thing should wonder in your mind, what is a point charge and how we are going to define a point charge. Okay, so point charge, the two charges should be point charge. So first you need to know what is the point charge. When we will say that the given charge is point charge or not. So in case when the size of the charge is very small compared to the average separation distance between two charges, or we can say when size of the two charges is negligible in comparison to the average separation of distance between two charges, the charges may be considered as point charge. But if it not happens and the size of the two charges are not negligible but have some constant value, or we can say is not comparatively negligible to the average separation, then the charges are not said to be point charge. So I think it is clear now when the two charges be said to be point if the average if their size are negligible in comparison to the average distance between two charges. Okay. So first point is the two charges should be point charges, and the second one is the two charges should be steady or stationary. Charges should be stationary. Now the third important condition we can consider, it is also the limitation of Coulomb's law, and this is that Coulomb's law does not work within nuclei distance. If the distance between two charges is greater than the nuclei distance, only then Coulomb's law is applicable. That is, Coulomb's law does not exist for the distance less than nuclear distance, that is 10 to the power minus 15 meter. If the distance between two charges is greater than 10 to the power minus 15 meter, the Coulomb's law will be applicable, either not. Okay. Now the fourth one we can consider, these are important points. Okay, you can note down anyhow. The fourth one is that Coulombian force or force of electrostatics is always conservative force. Electrostatic force is a conservative force. Electrostatic force is conservative force या conservative in nature. The second one, next one we talk about when we talk about Coulomb's law is similar to Newton's gravitational law, but in what aspect? In the aspect that both of these two laws are inverse square law. So Coulomb's law is similar to Newton's gravitational law. Newton's law of gravitation. As both are inverse square law. That is, force between two charges or two bodies is inversely proportional to the square of the distance separation of distance between two. Now the last one we can consider when we talk about Newton's law of gravitation and Coulomb's law of electrostatics, we found that Coulomb's law of electrostatics, or we can say electrostatic force of attraction or repulsion acting between two charges, is greater, far more greater in comparison to the gravitational force, uh, which is always attractive in nature, acting between two bodies. So, if we talk about the electrostatics force between two electrons, is about 10 to the power 43 times to the gravitational force working between them. While we talk about electrostatics force acting between two protons, it is about 10 to the power 36 times greater than the gravitational force acting between two protons. So the next point will be electrostatics force, electrostatic force are greater than gravitational force, greater than gravitational force, gravitational force. Another next point we can mention the vector form of Coulomb's law. So note it also.